So Russ, this is the still house here at the Highland Park. So what actually happens in this process?
Well, Jerry, as you can see here, we've got 4 stills. The far off pair are our wash stills. And what we do there is we charge 14,600 litres of wash into each of these stills. And we basically boil up the liquid, and the vapours of all different boiling points. So the vapours ascend up the still body through the line arm into the condenser, and the vapour is then condensed into a liquid and it runs back into the safe. But basically the distillation process is all about separations. It's about separating the water from the alcohols and the flavour congeners, and it's all based on the volatility of each of the components.
So is there a difference between the wash stills and the spirit stills, or
they're run exactly the same? But when we collect the low wines from the wash stills, and we'll collect that in the region of 22% alcohol, the low wines and the faints and the foreshot all mixed together is then charged into the spirit stills. And again, it's boiled up exactly the same way, but this time, instead of having one complete run of low wines into the receiver, we've got 3 fractions of the spirit run. The first fraction is foreshot, and that's some of the very, very volatile components that we don't really want. But we don't want to throw them away. We collect them for the next distillation. The middle part, which is right the way down to 64.5% alcohol, is the middle run. That's what we term middle run, and that's the new mixed spirit we want to collect for filling in the warehouse. At 64.5% alcohol in the run, we then change the dish in the safe, and we collect that run, this part of the run, as faints, and that's run right the way down to 1.8%, of which then we put the still off and discharge, and that product, or the byproduct from the second distillation process, is called spent lees, and we use spent lees to preheat the next distillation run.
Right. And is there any particular reason why they're made out of copper?
Copper's a very, very important material for us in distillation, mainly to do with the flavours and the quality of the new mixed spirit. It will mask, it will remove some of the very sulphurous components in the product. You could distill with stainless steel, but unfortunately the new mixed spirit you would collect from there, you wouldn't be able to drink later on after maturation. It's really just copper acts almost like a catalyst to improve the flavour of the new mixed spirit.
And the condensers themselves, what are they made out of? Are they made out of copper as well, or are they made out of steel? Or?
Our condensers, again, are made out of copper, exactly the same reason. It's to remove any of the very volatile sulphurous components from the new mixed spirit.
And what type of condensers do we use? Are they worm tub? And
our condensers are called shell and tube. They basically great big tubes with inside these tubes about 150 smaller tubes. Yep. Up in the inside of each individual small tube goes the water, and that's acts as a cooling agent, and the vapour comes into the top of the shell, and they hit the outside of this tube, and that condenses the vapour into a liquid.
So is there a greater interaction with copper in the still or in the condenser, or is it about the same?
The head space, primarily in the wash cell, there's more interaction with the vapours. And as you climb up the still and into the top of the condenser, there's far more interaction there.
And is there any, all stills seem to be different shapes and sizes. Is there a particular reason why ours are this size, or is it just what we've grown up with?
Well, it's one of those very fascinating points, Jerry, that when you go around all distilleries, any repairs, any changes to the stills are they're protected. What we mean by that is, if we're replacing the stills, we'll replace them exactly like for like, because the reflux action in the stills, which is basically the vapour ascending up the still and falling back down to where it came from, the still shape has got a huge impact on that. It's very, very important to keep it exactly the same as it always has been, because quite simply, if we change the still shape, potentially we will probably change the new mixed spirit quality and character.
So if our stills were twice the height, what would you expect the difference to be?
Basically, the reflux action would be much greater. You would produce a very, very light new mix spirit, and as we predominantly fill into first full sherry casks, the influence of the wood would be too great on the new mix spirit.
So because we are short and dumpy, I suppose, we create a heavier type of spirit?
That's exactly right. A heavier, more waxy, more oily new mix spirit that's able to withstand the influence of the wood, and it complements one another.
And how long does a still last for? Do they have to get replaced on a regular basis, or do they last forever?
No, unfortunately, I wish they did last forever. Difficult to say. It really depends on how much usage, as you can imagine. But the wash still heads and the wash still condensers normally wear first, followed by the spirit still bodies. And probably you might get 10 years out of a wash still head and condenser, and maybe 12 to 15 years out of a spirit still body. But to be honest, as I said before, it really all depends on how often you're using them, and the production levels of the distillery will dictate that.
So to kind of finish off the process, we've taken our beer, we've stuck it through the two wash stills, raised it up to 22% alcohol, stuck it through our spirit stills, and then we've taken that middle cup. What happens with it then?
Well, the middle cup on average is about 69.8% alcohol in strength. We then send it through to the filling store, and that's then ready to fill into casks.
Nice and simple. Thank you.